Welcome back to our YouTube channel Incredible Maths. In this video we will solve problems from partial differential equations asked in CSIR NET February 2022. So here we solve 4 problems, 2 from part B and 2 from part C. First we will solve the problem with question ID 491. So given that the Cauchy problem uy minus xux plus u minus 1 equal to 0 with the condition u of x comma 0 equal to sin x. So we need to find u of 0 comma 1. So the given Cauchy problem can be solved using method of multipliers or Lagrange's method. First we will write the auxiliary equation. So the auxiliary equation is dx by minus x is equal to dy by 1 equal to du by 1 minus u. So this can be written as, so general form, minus x xux plus uy equal to 1 minus u. So the coefficient of ux will come in the denominator of dx, and similarly we have dx by minus x equal to dy by 1 equal to du by 1 minus u. So we need to find two functions. So here, so we will take the first two, dx by minus x equal to dy. Therefore dx by x equal to minus dy. So when we solve, we get log x equal to minus y plus log c1. So therefore x is equal to e power minus y into c1. So that is nothing but c1 e power minus y. Therefore x e power y equal to c. So this is one function. So similarly we need to find the other function. So for that we will take the first and last. So dx by minus x equal to du by, so we will make some change, modification in the denominator. So to be, this can be written as minus of u minus 1. So therefore get dx by x equal to du by u minus 1. So therefore so this is nothing but log x plus log c2 equal to log u minus 1. So therefore log u minus 1 equal to log of xc2. So we have u minus 1 equal to xc2. So therefore u minus 1 by x equal to c2. So this is another function. So the solution is given by pi of c1 comma c2 equal to 0. So that is pi of x e power y comma u minus 1 by x equal to 0. So that is u minus 1 by x equal to some f of x e power y. So when we simplify, we get u equal to x times f of x e power y. So this will become 1 plus. Okay. So this is our u equal to 1 plus x f of x e power y. So we need to find this function f. So using the given condition, u of x comma 0 equal to sin x. Now u of x comma 0 equal to sin x. So that means you have to put x equal to x and y is equal to 0. So therefore, so the above equation becomes sin x equal to 1 plus x times f of x. So e power 0 will become 1. Therefore sin x minus 1 by x equal to f of x. So therefore, so now equation 1 becomes u equal to 1 plus x. So f of x e power y is sine of x. So sine of x e power y minus 1 by x is x e power y. So this x we can cancel. So therefore our u is u equal to 1 plus sine of x e power y minus 1 divided by e power y. So we need to find u of 0 comma 1. So u of 0 comma 1. So that means you have to substitute x is equal to 0 and y is equal to 1. So 1 plus x is equal to 0 becomes sine 0 minus 1 divided by e power y is equal to 1. So therefore you get 1, sine 0 is 0, so minus 1 by e. So the answer is u of 0 comma 1 equal to 1 minus 1 by e. So the option A is the correct answer and all other options are wrong. So this is a part B question. So now we move on to the second question. So question ID 492. So here we need to find which of the given partial differential equation is not parabolic. So the classification of PDE is done based on the value of b square minus 4ac. So this we have to find from the general form of the equation a times uxx plus b times uxy plus c times uyy plus some function. So it may involve x, y, u equal to first derivatives. So from each of the equations we need to find b square minus 4ac. So here this is a and this is okay. So here there is no second order derivatives. So there is only a. So that means here a equal to x square, b equal to 0 and c equal to 0. So b square minus 4ac equal to 0. So therefore this is a parabolic equation. So now we will see b. So this is a and this is b and there is no c, so c is equal to 0. So that is here a equal to x square, b equal to minus 2xy and c equal to 0. So we will calculate b square minus 4ac. So this equal to, so b square is 4x square y square minus 4x square, c is 0. So this is equal to 4x square y square. So this is not equal to 0. So therefore this equation is not parabolic. So implies b is not parabolic. So therefore this is the correct option. So anyway we will check option C and D. Option C, so this is our A and this is B and this is C. So b square minus 4ac equal to 4x square y square minus 4x, a is x square and c is y square. So this is nothing but 0. So this is parabolic. And similarly we will check option D. Option D, so this is our A and this is B and this is C. Now b square minus 4ac equal to 4x square y square minus 4x square times y square. So this is equal to 0. So this is implies it's a parabolic equation. Therefore the only non-parabolic equation is option B. So this is a correct option and all other things are wrong. So next we will see the question. So these the remaining two questions are from part C. So we need to check which are the following expressions for u are the solutions of the given partial differential equation ut minus e power minus t ux plus u equal to 0. So with the condition u of x comma 0 equal to x. Now, so this is a Cauchy equation. So we rewrite ut minus e power minus t ux equal to minus u. So therefore the auxiliary equation is u is a function of two variables t and x. So dt by 1 equal to dx by minus e power minus t. So this equal to du by minus u. So we will take the first two. So dt by 1 equal to dx by minus e power minus t. So this implies minus of e power minus t dt equal to dx. So when we integrate, we will get e power minus t. So minus e power minus t by minus 1 equal to x plus some constant c1. So this is nothing but e power minus t minus x equal to c1. And taking first and last, so that is dt equal to du by minus u. So this is du by u equal to minus dt. So when you integrate, so log u equal to minus t plus log c2. So therefore u equal to c2 e power minus t. So that is u by e power minus t equal to c2. That is nothing but u e power t equal to c2. So this is the second function. So the solution is pi of c1 comma c2 equal to 0. So that is pi of e power minus t minus c, so minus x, comma u e power t equal to 0. So therefore e power, now u e power t equal to f of e power minus t minus x. So therefore u equal to e power minus t f of e power minus t minus x. So we need to find this f. So this f can be found out using the condition u of x comma 0 equal to x. Now u of x comma 0 equal to x. So this implies x equal to e power minus t f of t equal to 0. So f of 1 minus x. So x e power minus t equal to f of 1 minus x. So now let 1 minus x is equal to some other variable y. So this implies x is equal to 1 minus y. So therefore, so from this we can replace x is equal to 1 minus y, 1 minus y e power minus t. So this is equal to f of y. So therefore f of y equal to 1 minus y e power minus t. So using this, so we can write this as u. So now this implies u equal to e power minus t. So f of x is, f of y is 1 minus y e power minus t. So therefore 1 minus e power minus t plus x. So this implies u equal to e power minus t 1 plus x minus e power minus t. So this is the correct answer. So the correct answer is u equal to e power minus t 1 plus x minus e power minus t. So since this is a part C question, so it has only one correct answer. So all other options are wrong. So other way to solve this problem is, so you can substitute each of these u in the given equation, and we have to check whether this u satisfies the given equation or not. So this is one more method. So next we will solve one more problem. So this is also part C question. So solve the partial differential equation x square u xy plus 3 u y square u equal to 0. The u of x comma 0 equal to e power 1 by x. So we need to check which of the following statements are true. So the given differential equation, partial differential equation, is a linear partial differential equation. So here u is the dependent variable and x and y are independent variables. So here the PDE is linear. So here the PDE is linear, therefore the first option is wrong. So we need to check whether the three options B, C, D are correct or wrong. So when we solve this equation using method of separation of variables, so let us assume the solution u of x comma y is the form some x of x into y of y. So therefore this given equation becomes, so x square, so u xy, so differentiation x dash of x, so simply write as x dash y dash equal to plus 3 y square xy equal to 0. So now this equation x square x dash y dash equal to minus 3 y square xy. So we will separate the variables. X square x dash by x equal to minus 3 y square capital Y by y dash. So this is equal to some constant k. So now x square x dash by x equal to k and minus 3 y square y by y dash equal to k. So x dash by x equal to k by x square. So when we integrate this one, so we get log x equal to x k x power minus 2 plus 1 divided by minus 2 plus 1 minus 1, and this one, so we will rewrite, so minus 3 y square by k equal to y dash by y. So therefore this is log y is equal to minus 3 y cube by k into 3. So this 2 will get cancelled. So this is log x equal to minus k x power minus 1 and log y is equal to minus y cube by k. So therefore x equal to e power minus k x power minus 1, and here y is equal to e power minus y cube by k. So therefore capital X equal to e power minus k by x and capital Y is equal to e power minus y cube by k. So our solution u of x comma y equal to xy. So this is equal to e power minus k by x into e power minus y cube by k. So this is our solution. So we have the condition u of x comma 0. So from this we can find the arbitrary constant k. U of x comma 0 equal to e power 1 by x. Now u of x comma 0 equal to e power 1 by x. So this implies e power 1 by x equal to, so e power minus k by x into e power y equal to 0, so e power 0. So therefore, so equating 1 by x equal to minus k by x. So this implies k equal to minus 1. Therefore, u of x comma y equal to e power 1 by x into e power y cube. So we need to find u of 1 comma 1. So u of 1 comma 1 equal to e power 1 into e power 1 cube is 1. So e power 1 plus 1 is e power 2. U of 1 comma 1 is e power 2. So this option is correct. So this option C is wrong, since u of 1 comma 1 equal to e square is not equal to e power minus 2. So here the equation is solved using separation of variables. So therefore option D is correct. So the correct options are option B and option D. So if you like the content of this video, kindly like and share with your friends. Also subscribe to our channel. Thank you.